So sine A plus cos A whole square is sine square A plus 2 sine A cos A plus cos square A. And you see that the same can be written as, if you combine these two, this will give you 1. And this 2 sine A cos A can be written as sine 2A. Okay? Similarly, if you have sine A minus cos A whole square, you can write it as 1 minus sine 2A. Okay? Now this will be needed in your question number 2 part B. Let me do that for you. 2B. Let me slide this a bit up here. Okay. And then we do this 2B. Look at this 2B. You have, this is 2B. We have cos A plus sine A over cos A minus sine A. I'm not writing this right-hand side for a moment. This is a very advanced kind of an identity. You will have to multiply the numerator and denominator with cos A plus sine A over cos A plus sine. I remember we have done a lot in our FSC like this, okay? So this is the left-hand side, okay? Now the numerator becomes cos A plus sine A whole square, and the denominator is A plus B into A minus B. So that is cos square A minus sine square A. I have just told you that this whole square, look at this here, sine A plus cos A. So you can write it as 1 plus sine 2A. And the ones who are familiar with the cos 2A formula, they know that this can be changed with the cos 2A. So now we can split 1 over cos 2A and then plus sine 2A over cos 2A. This will give you secant 2A, and this would be tan 2A. That is your right hand side. Yes or no?
Yes.
We want to see this is 1 minus tan square A over 1 plus tan square A. Okay, you see 1 minus tan square A is 1 minus sine square A over cos square A. Okay. Oh, I have changed my plan. I can simply write it as secant square A. Yes, because you know 1 plus tan square A is secant square A. I take the LCM here. This becomes cos square A minus sine square A over this cos square A. Now this secant square A means 1 over cos square A. So when I split this, I change this into this multiplication, it becomes like this. Understood this step? This secant square A over here is actually 1 over cos square A. Yes? And then if you have A over B divided by C over D, this actually means A over B times D over C. So its reciprocal is going to be this cos square A over 1. That I was not writing that 1 intentionally. So this cos square A is cancelled with the cos square A. And you guys know that cos square A minus sine square A is cos 2A. That is cos 2A. Okay? I have taken one identity from the P1. In fact, this is also the tan is sine A over cos A. That is also taken from your P1. Okay? Okay, guys, this is your D part, 2D. We have to prove all this cos 2A plus sine 2A minus 1 over blah, blah, blah is equal to tan A. Achha, I'm feeling that if I combine these two, you see, What is 1 minus cos 2a? Isn't it 2 sine square a, Hannah? And what is 1 plus cos 2a? That is your 2 cos square a. Oh, yes. He has
Sir, we
split.
have cos 2a minus 1. We don't have 1 minus
No
cos 2a.
problem. We
We
can
don't
take
have one
minus.
minus.
We can take minus common bit. So if you have this minus and this plus, you can write minus over here. Hmm? Yes or no? I think you
Yes.
must say yes. So I am going to write this as minus 2 sine square a, and I'll change this with 2 sine a cos a. Okay. And I'll combine these two. I'll write this as 2 cos square a, and I'll write minus 2 sine a. And another method is striking my mind. I'll share that with you as well, inshallah. Okay, so I'm going to take minus 2 sine a common from the numerator. Okay, so I have sine a and minus cos a inside the brackets. I'll take 2 cos a common from the denominator. Let me take minus 2 cos a so that I can have inside sine a minus cos a. Okay. Oh, this was so cool. All of this cancel, this cancel, this cancel, and you have been left with tan a. This was really fun. I really loved it. That is your right hand side. Okay, bacho? Did you get it? Hmm. I want to do this with another method, if you allow me. There is another way that is striking my mind. Let me do it with that. Okay, you can
सर
take another.
एक इस मेथड से पूछते हैं
Mhm.
सर आपके पास 2 साइन है और cos कहाँ से आया
Or putar sine 2a. Sine 2a is 2 sine a cos a. Hmm?
ओ मैंने 2 नहीं देखा सर
Acha, theek hai. Okay, now let me do it with another method, and you will love that method as well. Let me do that. Okay. Okay. Just see. Uh, because my eyes just went on to this area, and I'm going to use this now. Okay, guys, see. Uh, 1 plus sine 2a is cos a plus sine a whole square, है ना? यही होता है ना? 1 plus sine 2a is all of this. ठीक है? And this is 1 minus sine 2a. So let me write the left hand side as I will be um, changing this with this cos 2a into cos square a minus sine square a. And like from all of this, I'm going to change this 1 into sine square a plus cos square a. That will give me minus sine square a. Oh, that's the same, I think, yes. And I'll change this sine to a with 2 sine a and cos a. I think it's the same. This is going to be cos square a minus sine square a, and I'll change this with plus sine square a and plus cos square a, and I have minus 2. Oh yes, it's the same. I thought if I could write this as a whole square, and then, okay, from here you see that this cos square is cancelled with this cos square a, this sine square is cancelled with the sine square a. Yeah, it's the same. And this is your minus 2 sine square a, and then you take a minus 2 sine a common. It's the same. It's the same. Okay. Minus 2 sine a into sine a minus cos a. And then you have the other one down here. This is going to be, let me change this color. Yeah, this is over. and you have minus 2 cos A common from here, and this is going to be sine A minus cos A. These are cancel, and you have tan A. It was the same, by the way. The first method was better.